This video lesson is on rational expressions and specifically how to reduce them to their simplest terms. So in another video, we went over how to find the restricted values, and the way to do that was by factoring the denominator. To reduce a rational expression, you'll have to factor the numerator and the denominator. Then you'll have to state the restrictions before you do anything else. And finally, you can reduce by canceling out common factors that exist in both the numerator and the denominator. When I say common, I mean that they have to be the same. But it's important that you state the restrictions first, because even if a factor cancels out, it still is going to apply in the list of restricted values. So that order is very important here. So here's an example. How would I do this? Well, I would factor the numerator and the denominator. If you want some factoring practice and you want to pause the video and give it a try, go ahead. I'm going to skip ahead and factor both of those. So these factor in the following way. The numerator as 2x plus 5 and x minus 3. The denominator as x plus 4, x minus 3. The second step that we had was to state restricted values. Those only come from the denominator. The numerator does not contribute in any way to the restricted values. So the restricted values are when I take each individual factor from the denominator, set it not equal to 0, and I isolate the variables. So those are my restricted values here. It's that x can't be 3 and it can't be negative 4. Then I can cancel out common factors. What's really, really important about canceling is that I can't cancel this x with this x. The only thing I can do is cancel entire factors. So only once I have factored can I cancel it. If I go back to the original, I can't cancel this x squared and this x squared. I can't cancel this x and this x. And I can't simplify the 15 and the 12 by dividing them by 3 or negative 3. I can't simplify factors that have been added or subtracted. I can only simplify entire factors once they have been factored, once they're multiplied. So only in this simplified factored version can I cancel out the x minus 3 and the x minus 3. They're gone. Side note, it's very satisfying to slash them out. And what remains is this expression, just the 2x plus 5 over x plus 4. Again, now because these are added, I cannot cancel out these x's. I could not simplify the 5 and the 4 if they were simplifiable. And both restricted values still apply. In this example, again, if you want to pause and give it a try, if you want to try to factor these, now's a good time because I'm just going to show the factored version. When this is all factored, this is what it looks like. My restricted values only come from the denominator. So I'll set each factor not equal to 0 and I'll isolate the variable. So my true restricted values here are 5 and negative 3 over 2. Now that I have done that, I'll see if there's a common factor in the numerator and denominator. In this case, there is. It's the 2x plus 3. So I cancel those out. And here's what I'm left with. Both restricted values apply. If you want to pause this one as well and give it a try, you can. I'm going to show the factored version. So for practice, if you want to try to list the restricted values, and if you want to try to reduce this entire thing, go ahead. But just as a reminder, you cannot do any of that simplification from the very original one. Only the factored one can be simplified by canceling out factors. So in this case, the restricted values are 3 over 4 and negative 2. 4x minus 3 is the cancelable factor, the factor that cancels out. And so my reduced version is this one. Again, here I cannot simplify these x's because they're added, subtracted. They are not multiplied factors. And both restricted values apply. And that is it.